Chapter 4, Work and Energy. Potential Energy. Activity 11.8. Take a rubber band, hold it at one end and pull from the other. The band stretches. Release the band at one of the ends. What happens? The band will tend to regain its original length. Obviously, the band had acquired energy in its stretched position. How did it acquire energy when stretched? The work done in stretching the rubber band is stored in it as potential energy. When the band is released, it tends to regain its original length due to its stored energy. That is, the band had acquired energy in its stretched position. Activity 11.9. Take a slingy as shown below. Ask a friend to hold one of its ends. You hold the other end and move away from your friend. Now you release the slingy. What happened? How did the slingy acquire energy when stretched? Would the slingy acquire energy when it is compressed? When released, the slingy regains its original length. The slingy has acquired energy due to work done during stretching. Yes, the slingy would also acquire energy when it is compressed. Activity 11.10. Take a toy car, wind it using its key. Place the car on the ground. Did it move? From where did it acquire energy? Does the energy acquired depend on the number of windings? How can you test this? The toy car moves when placed on the ground. The work done in winding is stored as its potential energy. More the number of windings, larger is the energy stored and larger would be the distance moved by the car. Activity 11.11. Lift an object through a certain height. The object can now do work. It begins to fold when released. This implies that it has acquired some energy. If raised to a greater height, it can do more work and hence possesses more energy. From where did it get the energy? Think and discuss. In raising the object through a certain height, the work has to be done against the force of gravity. This work gets stored as potential energy in the object. Larger the height through which the object is raised, larger is the work done on the object, and hence more is the energy acquired by the object. In the above situations, the energy gets stored due to the work done on the object. The energy transferred to an object is stored as potential energy if it is not used to cause a change in the velocity or speed of the object. That is, in the above situations, the work done on the object is stored as potential energy. You transfer energy when you stretch a rubber band. The energy transferred to the band is its potential energy. You do work while winding the key of a toy car. The energy transferred to the spring inside is stored as potential energy. The potential energy possessed by the object is the energy present in it by virtue of its position or configuration. The potential energy is basically a stored energy. Whenever we perform a work or work has been performed on a body, this changes its position or changes its configuration. Then this energy gets stored in the correct configuration of the body, and as a result, when the body is released, that energy is being utilized by the body to move or to acquire a certain velocity or to come back its original position. So that energy, what we called, is potential energy. Therefore, the potential energy possessed by the object is the energy present in it by virtue of its position or its configuration. Activity 11.12. Take a bamboo stick and make a bow as shown in figure. Place an arrow made of a light stick on it with one end supported by the stretched string. Now stretch the string and release the arrow. Notice the arrow flying off the bow. Notice the change in the shape of the bow. Explain the observation. The potential energy stored in the bow due to the change of shape is thus used in the form of kinetic energy in throwing of the arrow. When the string is stretched, the work done on it is stored as its potential energy due to the change in shape. When released, this energy is used in the form of kinetic energy in throwing of the arrow. The bow regains its original shape. Potential energy of an object at a height. An object increases its energy when raised to a height. This is because work is done on it against gravity while it is being raised. The energy present in such an object is the gravitational potential energy. When we raised an object to a certain height against the force of gravity, we are performing some work. The force of gravity is always acts in the downward direction. This work done is get stored as potential energy in the object. When the object is released, it falls the ground again, and that potential energy has been used by the object to come to the ground again. The energy of the object rises when it is raised to a certain height because the work is being done on it against the force of gravity. So, that kind of potential energy is called gravitational potential energy. The gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to that point against gravity. It is easy to arrive at an expression for the gravitational potential energy of an object at a height. Consider an object of mass small m. Let it be raised through a height small h from the ground. A force is required to do this. The minimum force required to raise the object is equal to the weight of the object mg. The object gains energy equal to the work done on it. Let the work done on the object against gravity be W. That is, work done W equal to force into displacement. Here force equal to weight of the object, that is m into g, and displacement is the height small h from the ground. Therefore, work done W equal to mgh. Since work done on the object is equal to mgh and energy equal to mgh units is gained by the object, this is the potential energy EP of the object. Therefore, EP equal to mgh. It is useful to note that the work done by the gravity depends on the difference in vertical heights of the initial and final positions of the object, and not on the path along which the object is moved. Figure 11.8 shows a case where a block is raised from position A to B by taking two different paths. Let the height AB equal to h. In both situations, the work done on the object is mgh. The work done by the gravity depends only on the initial and final height of the object where it was in the initial and final positions, and not upon the path covered by the object to reach final point. For example, let one object is moving in a straight path and reaches the height h. A is the initial position and B is the final position. Consider another object is followed different path and but reaches the same height h. Now the initial and final positions of the two objects are same, which is named as A and B respectively, even though the path that they had followed is different from each other. So, let's say path 1 and path 2. We see that path 2 is greater than the distance covered by the object in path 1. Even then, they had reached same height actually. So this work done on the object in both the paths are the same. Hence, their potential energies are also the same. In both the situations, the work done on the object is mgh. Potential energy of an object is path independent. Whichever path they are followed, you must have same potential energy if you raised to a certain height h. Numerical application. Example 11.5. Find the energy possessed by an object of mass 10 kg when it is at a height of 6 meter above the ground, given G equal to 9.8 meter per second square. Solution. Mass of the object m equal to 10 kg. Displacement or height h equal to 6 meter and acceleration due to gravity g equal to 9.8 meter per second square. Therefore, potential energy equal to mgh. We have to substitute the values in the equation, then we will get the potential energy equal to 588 joule. Next one. Example 11.6. An object of mass 12 kg is at a certain height above the ground. If the potential energy of the object is 480 joule, find the height at which the object is with respect to the ground, given G equal to 10 meter per second square. Solution. Mass of the object m equal to 12 kg. Potential energy EP equal to 480 joule. EP equal to mgh. We have to substitute the values in the equation. H is not given, we have to find it. Then we will get h equal to 4 meter. The object is at the height of 4 meter. Summary. Potential energy is defined as the energy possessed by an object by virtue of its position or configuration. Second, potential energy equal to mgh. The SI unit of potential energy is joule J. Potential energy of an object is path independent. That is all in this topic. Let us learn conservation of energy in our next topic. Thank you.